Module 4, problem number 15. Calcium is essential to tree growth because it promotes the formation of wood and maintains cell walls. In 1990, the concentration of calcium and precipitation in a certain area was 0.15 milligrams per liter. A random sample of 10 precipitation dates in 2007 results in the following data table. Complete parts A through C below. So here we have the link for our data set, but let's go ahead and read part A first. State the hypotheses for determining if the mean concentration of calcium precipitation has changed since 1990. So we know we're looking at the mean because it says here determine if the mean concentration, and we always know that our null hypothesis is always that it's equal. That's always our baseline. Our null hypothesis is equal to that value that we're testing, which is 0.15 milligrams per liter. And here it says we're testing to see if it has changed. That means we're not looking to see if it's if it's increased or decreased. We're looking to see if it's changed at all. So that means our alternative is that it's not equal to 0.15. So let's check our answer. Nice work. Construct a 99% confidence interval about the sample mean concentration of calcium precipitation, the lower bound and upper bound. So let's go to open our data set and then click on that link to open in StatCrunch. Go ahead and close this because we're going to be entering our answers. So go ahead and go to stat. Again, when we deal with the hypothesis test or construction, the confidence interval for the mean, we're going to t-stats to use the student's t-distribution. We have one sample and we have data since we were given the data set. We're going to select that column, var1, as you see right here where our data is. Then we're going to check confidence interval for the mean. Here it asks us to construct a 99% confidence interval. So we need to put in 0.99 and click compute. And it gives us our lower and upper limits. So here it says round to 4 decimal places as needed. So here's our lower limit. We have 0.0666 because that 5 rounds up because of the 8. And then the upper bound is 0.2438. Let's check our answer. Fantastic. Part C, does the sample evidence suggest that calcium concentrations have changed since 1990? Now remember, when we have a two-tailed hypothesis test, that means when we're looking to see if the statistic has changed, if the mean has changed, then we can use a confidence interval to decide to make our decision. So here we want to see if that value 0.15 is in our interval. It is because it's greater than 0.06 and it's less than 0.2438. So we know that it's in our interval. That means it's really unlikely that it's changed. So we're going to say no because the confidence interval contains 0.15. If 0.15 was not in that confidence interval, it would tell us that we had enough evidence to suggest that it had changed. So let's check our answer. Nice work. If you have any questions about problem number 15 in Module 4, let me know.